It's not just eruptions from under the ice sheets that we're being warned about. Eruptions on the surface of the sun also have the potential to impact all our lives. Scientists are warning of the catastrophic and long-lasting impacts of solar superstorms. They believe it's only a matter of time before one of these violent events is directed at Earth, and that could knock out satellites and power supplies, meaning everything from transport to medicine to the internet would be negatively impacted. Imagine a world where all the electronics go dead. No cash machines, no petrol pumps, no mobile phones, no hospital equipment. That is the extreme version that they are describing. We spoke to Ash Dale from the University of Bristol. He's part of the advisory group of scientists for the UK and European space agencies looking at the problem of the sun and possible threats from it. That's the international task force dubbed SolarMAX. He's also the author of this new report in Physics World. And we also spoke to Dr. Pete Worden, director of NASA Ames Research Center in California, an expert in this field. First, Ash says that we may just be lucky that we haven't been hit yet, but that can't last.
We've recently come to realize that the nature of our nearest star is far more hostile than we originally thought, in particular by observing data from the Kepler spacecraft, a spacecraft looking at hundreds of thousands of other stars in our galaxy, in particular looking for other planets. We've accumulated hundreds of thousands of years worth of data on those stars just like ours, and we have found that major solar events occur relatively often, on the order of every couple of centuries. Now, with such an integrated electronic infrastructure here on the ground, and with about 1,000 operational satellites up in space, there could be serious implications if a major event were to happen in the coming years.
Give us a breakdown of exactly what would happen. What are the problems we're likely to face?
So satellites would be damaged to some level, solar panels would be damaged, and therefore the life of those satellites would be reduced. Some may even be destroyed. A major solar event could cause enough damage that would take on the order of a decade to recover.
Satellites we use for communications, increasingly for GPS, for satellite
communications, transportation, agriculture, a whole range, thousands of applications that are very intricate to our way of life. Now, on Earth, there are these things called transformers that are connecting up the power grid. And if a large enough geomagnetic surge were to occur, these transformers would melt. Now, transformers cost on the order of about $10 million, and power companies rarely hold backups on site. Take about a year to manufacture. Now, if a major solar event were to occur and a number of transformers were to fail, we're looking at widespread power outages. And imagine if we turned the electricity off tomorrow and it was off for a couple of months. What would happen?
Pete, these threats sound scary. How real are they?
Well, we see a lot of solar activity that has impacts. For example, a few months ago, Ames launched a satellite called KitSat. It was a small satellite that went in orbit, and solar activity caused an upset of its electronics, and we weren't able to get it fixed before it deorbited. So there are losses of satellites. I think Ash is exactly right. There's considerable concern, and a lot of it's not that we weren't aware the sun has this activity. It's that because we're so much more dependent on connectivity, much of that space connectivity, we're a lot more concerned and vulnerable about things. And of course, with NASA, we're beginning our next steps into the solar system. We're planning a mission here early the next decade to actually go and redirect a small asteroid. We're on our way to Mars. This activity has a lot of impact on deep space missions. As long as we stay in low Earth orbit, we're protected by the Earth's magnetic fields, and the activity around it. But as we go deeper into space, we need to understand the effects of this and how to predict it and understand it. So it's a growing concern for NASA. We've long had a heliophysics effort, and this is one that has a lot of attention. Now, I might add, one of the interesting points is that the funding for heliophysics goes in phase with the solar activity, only delayed about a year or two. So since we're close to maximum, we hope for our maximum funding in the next couple of years. But these concerns come and go. But I think it's time that we start understanding how to live with our star, and that's one of NASA's major programs.
And you say we're at close to maximum. What does that mean? That this activity of the sun goes in cycles, does it?
Absolutely. For reasons that we're just beginning to understand, the sun has these magnetic fields that it's sort of like a rubber band, and the sun winds them up every 11 years, and the band starts to snap. At the maximum, we see a lot more sunspots, a lot more activity. As these rubber bands or magnetic rubber bands snap, you end up getting huge explosions on the sun, which are called solar flares, and some of these will throw a lot of material, solar mass ejections they're called, into the interplanetary medium. And if the Earth's in the path of those can be a major solar storm on Earth. So those happen at a maximum every 11 years, and then it kind of quiets down. It's sort of like hurricane season on Earth, where we're starting to see the hurricanes in space increase considerably.
If they're every 11 years, Ash, doesn't that mean that we've faced this threat and come through it unscathed in the past?
Well, actually, the largest known solar event in our historical records, the Carrington event, occurred during a solar minimum. So we go through these phases, but that by no means that we're not going to have any solar events occurring.
Well, let me mention the Carrington event, which was probably the first really recorded disturbance. There was a huge sunspot on the surface of the sun, and it caused currents in telegraph lines. In fact, there's a lot of reports of telegraph operators sitting at their telegraph operation, and the surge that came through those lines actually blew them back out of their chair and knocked out a lot of the telegraph. Now, granted, in 1859, we weren't nearly as dependent on technology, but we can extrapolate that if one of these events occurred today, it would do a lot more than blow a few telegraph operators out of their chair. As Ash said, it could knock out a lot of our electric grid, knock out our long-term communications, and in some sense, these large events could send us back to a pre-industrial and pre-technological era if it was really bad. It's across the board, not just the sort of alarming, once every century or two activities, which we're certainly concerned about, but also the day-to-day impacts of space weather.
So you've given us the warnings, and they are very scary sounding. Is there anything that can be done? What steps can we take to protect ourselves?
One of the biggest things that would help would be an increased ability in solar weather forecasting. So we never really look at the sun from more than one side, which is a bit of a problem when you're trying to forecast the sun's weather. You need to take a look at the entire picture to create better forecasts. And a concept we developed was an array of small satellites around the sun, looking at it from a 360-degree perspective. And these satellites would be slightly tilted from each other, their orbits, such that we can view the major features on the sun in full 3D. Not only would these satellites be looking at the sun, but they would be measuring the magnetic field lines around the sun. Collecting all of this data would help drastically increase our knowledge of how the sun works.
And Pete, looking forward, are you optimistic that we can actually overcome some of these potential problems, or are you slightly concerned?
Well, of course, weather is something that you can't directly do anything about, but I'm confident with knowledge of what's going on and better measurements we can do a lot. It's a very promising future, but I might just say that the world is entering a what I might call a space economy, and we're going to be very dependent on space and things that happen in space. This is going to be a key part of it.
As a species, we've never been more vulnerable to the volatile mood of our nearest star, but it is well within our capability as humans to protect ourselves. Really, the danger does not lie within the sun itself, but within the ignorance of the public and the politicians.
Ash Dale at the University of Bristol, and also Dr. Pete Worden from NASA Ames Research Centre, describing the impact on Earth if a solar superstorm hits. This is Science in Action from the BBC. I'm Jack Stewart.